monetary word problems, or word problems involving money. I want to start out by doing a fairly simple example. A piggy bank consists of nickels. How much money is in the piggy bank? Well, this is a fairly easy problem. We could quickly figure this out, but I want to establish a formula for these problems because the problems are going to get much more difficult than this. So this is the formula that we're going to use. Money is 25 cents times the number of quarters, which is 10, and that, of course, $2.50. So this is the formula that we're going to use. Let's go ahead and figure out how much money is in this piggy bank. There's 5 nickels, 5 cents. There's 5 nickels. So we get, what's that, 25 cents. There are 6 dimes, and the value of a dime is 0.10. $0.35. Okay, so this is the formula that we're going to use throughout this lecture. Now let's do a typical problem that you might find in an algebra book. Okay, Wendy has a purse consisting of quarters, dimes, and pennies totaling $3.77. She has 6 fewer dimes than quarters. A lot going on here, a lot tougher than the piggy bank problem. So what we need to figure out is what is going to be our variable throughout this problem. Well, I'm going to just write a note to myself that I have quarters, dimes, and pennies. Dimes and describes my pennies. Now remember, throughout all of these word problems, we have to come up with one variable that's going to work with each of these components. So let's try to read the problem again. Wendy has a purse consisting of quarters, dimes, fewer dimes than quarters. So the number of dimes is going to be the number of quarters, and the number of pennies is Q plus 5. So we've got Q quarters, Q minus 6 dimes, and Q plus 5 pennies describing each component of our problem. Now, let's go back. Well, we've got Q quarters. The value of a quarter is 0.25. So we have 0.25, that's the value of a quarter, plus times the number of dimes. The value of a penny is 0.01 times the number of pennies. And that, of course, is equal to the total, which is 377. Now that is a linear equation. Again, if you're not familiar with solving decimal linear equations, take a look at the decimal linear equation lecture, and we'll get you caught up to speed. Remember, to get rid of the decimal, we have to multiply by the appropriate power of 10. In this case, we're going to have to multiply by 100 to move every decimal 2 places, so I'll do that. Multiplying by 100 here. Multiplying by 100 here. 2 places, so I just get 1 equals multiplying by 100 here. Because my decimals are gone. Now let's just distribute combined like terms and try to solve. So 25q distributing plus 1q plus 5 equals 3. Let's combine like terms. 25q plus 10q is 35, plus 1 more is 36q. And a positive 5 is negative 55. With each step, the linear equation becomes easier and easier for us. On 36q is equal to, and now to solve for q, we divide both sides by 36. So we think q is equal to 12. Now, let's take a look at the original problem. In the original problem, we were asked to solve for how many of each and how many pennies. Well, remember, we said that there were 12 quarters because q is equal to 12. If q is equal to 12, then q minus 6 is equal to 6, which means there are 6 dimes. If q is 12, that would mean we have 17 pennies. Now let's just check and make sure. Now how can we check? Well, we know that the total is $3.70. 12 times 0.25. What's that? 12 quarters would be $3. 6 dimes, so that's pretty easy. 6 times 0.10, that's 60 cents. And 17 pennies is 17 cents. And the desired $3.77. So that's how we attack monetary word problems. Try to get a variable that describes each component and then assign value to your variables. And then you get a fairly easy linear equation involving decimals.